And people say, no, it's not the same. Good, you all win. Let's show you why. Let's say this is log base 3, and let's say x is 3. And now this quantity is squared. And then on the other side, again, it's x. We're going to let x equal 3. So this would be 3 squared. So in this one, we would evaluate inside our parentheses first. So if we're evaluating log base 3 of 3, what's log base 3 of 3? 1. And then we're doing 1 squared, which is just 1. In this next parenthesis, I have inside log base 3 of 3 squared. This was a shortcut. What's log base 3 of 3 squared? 2. Is 2 equal to 1? No. So it's a difference when you're squaring the whole log expression versus just squaring the argument on the log, right? Big difference. So we want to sort of keep that in mind. It's not the same. So let's say I have log base 3 of x quantity squared minus 4 times log base 3 of x minus 12 is equal to 0. And I want us to solve for x. Hey, what is it that I really, really hope you guys see? Lily? You got it. So right now we could potentially factor this y. I have some quantity squared, right? I have log base 3 of x, that quantity is squared. Then don't I have, again, that log base 3 of x to the first power? So I have two of the same bases, but one exponent is double the other. And isn't that the ideal scenario for factoring? We need an x squared and an x. But I'm not going to factor like this. I'm going to use substitution. So I'm going to let m equal log base 3 of x. So if I'm letting m equal log base 3 of x, what I end up having is an m squared minus 4m minus 12 equals 0. And now this looks a lot less intimidating, doesn't it? And we realize we can absolutely factor this. We're going to have an m minus 6 and an m plus 2 equals 0. So when we solve, we're going to get m equals 6, and we're going to get m equals negative 2. The problem is I love substitution because visually it makes it so much easier to see what we're going to do. But then it's sort of like a double-edged sword. Students just want to move on once you solve for m. But are we finished? No, we're not finished because we use substitution. I now have to substitute back. I'm not solving for m. I'm solving for x. So now I'm going to substitute back in, and I'm going to say log base 3 of x is equal to 6. And log base 3 of x is equal to negative 2. How do you think I'm now going to solve for x? Violet? Divide by what? I can't divide by just log 3 because the log 3 needs its argument attached to it. So I can't just divide by log 3 without an argument. No? Good. I can put this back into exponential. So we're going to put back in exponential. So how do we put this back into exponential? Well, my base is 3. My exponent is what? 6, and that should equal x. And remember the rule I made. What was the rule for exponents that I let you guys use? Ariana? Good. If the exponent is 5 or less, you have to multiply it out. On the last test, guys, some of you had an exponent of 5 and you left it in exponential. You had to multiply that out. So the rule is if it's 5 or less, multiply it out. But 6 is more than 5. So are we allowed to leave it like this? Yes. All right, now we're going to do the next one. So this is going to now put back into exponential. Can somebody put this into exponential for me? Exponential. Ira? Not 3 to the, you got it. 3 raised to the negative second power equals x. And isn't 3 to the negative second power 1/9? Okay, but because initially it was a log equation, do we still have to check to make sure that all our arguments are okay? And what am I checking to make sure when I say to make sure the arguments are okay? What am I checking to make sure of? No negative arguments. So if I plug this back in, 3 to the 6 or 1/9, do we all agree my arguments stay positive? So we're okay? All right, so both answers are acceptable. Again, we're solving for x, same direction. 7 raised to the 2x power minus 7 raised to the x power equals 20. So what is it that I hope you realize? I hope that you realize we have the same base of 7, right? And one of the 7s is raised to the 2x power, the other is raised to the x. So since I have the same base and one exponent is double the other exponent, does this make it a good case for factoring? Yes. So I'm going to use substitution again, just because I like it. So we're going to let m equal 7 to the x power. So then I end up with an m squared minus m. And what do you think I should do with that 20? Move it over. Minus 20 equals 0. So once again, we can factor this. So I'm going to have an m minus 5 and an m plus 4 equals 0. And then we solve. Are these my final answers, 5 and negative 4? No, because I use substitution, I need to now substitute back in. So we're going to have 7 to the x power equals 5 and 7 to the x power equals negative 4. So there should be a red flag here. Does anybody know what the red flag is? Charlie?
X is in the exponent.
Yeah, but we're good at that. There's another red flag. Yeah. Vivek? Yeah, so right now, is there any way possible if I have a base of 7 and I raise it to any number, real number, exponent under the sun, will it ever yield me a negative number? There's no way. There's no way if I have a positive base, no matter what real number I raise it to, it will never give me a negative outcome. So what does that mean right there? 7 raised to the x power equals negative 4? It's an extraneous solution, right? So we're rejecting that. All right, so now we're down to one solution. And now Charlie mentioned there's an x in the exponent, which is also a problem, but it's not a red flag. It's just a problem that we have to fix. Who remembers how do we get x out of the exponent since I can't make 7 and 5 into the same base? Not possible. So how am I going to get the x out of the exponent? Log, good. We're going to log just one side? Both sides, perfect. So we're going to log both sides. So I'm going to have log of 7 to the x power equals log of 5. And now once I've logged both sides, can I bring that exponent of x to the front of the log? So now I have x times the log of 7 equals the log of 5. My goal is to solve for x. If my goal is to solve for x, what should I do? Perfect. We are now going to divide by log of 7 on both sides. And so this is my calculator ready form. So x is equal to log of 5 divided by the log of 7. And then we go to our TI-84. And I'm going to type in exactly what our calculator ready form said. We're going to type in log of 5, close those parentheses, divided by log of 7. And if we're rounding to the nearest thousandth, we're 0.827. And this is our answer. I want you guys to try this one on your own. Okay, so is this a good problem for substitution? I think so. And I see that we have 3 to the 2x and 3 to the x, so I'm going to let m equal 3 to the x. So once again, we're getting m squared plus 2m. I'm going to bring that 8 over, minus 8 equals 0. Perfect form for factoring. So we're m plus 4, m minus 2 equals 0, and we get m equals negative 4 and m equals positive 2. We now have to substitute back in. So I'm going to get 3 to the x equals negative 4. Is this a red flag? Yes. Why is it a red flag? because of the negative. No positive base of 3 can ever turn into a negative 4, so that is going to be rejected. So now we're going to have 3 to the x equals 2. Unfortunately, I cannot make 2 into a base of 3 or 3 into a base of 2. So I'm going to have to think of another way to solve for x and to get it out of the exponent. So we will log both sides. And when we log both sides, I can bring that x into the front. And now I want to solve for x, so I'm going to divide by the log of 3. And our calculator ready form is going to be log of 2 divided by the log of 3. How many people got the correct calculator ready form? Perfect. And so now we're going to get in our calculator log of 2 divided by log of 3. I don't know what it is. Is it 0.631? Is that what we got? Perfect. All right, next one. Okay, so even though this seems a little bit intimidating, we're going to take it step by step. So what is your instinct telling you to do your first step? Well, you got it. Get rid of that denominator, multiply that 2. And when I multiply that 2, I'm going to get 3 to the x plus 3 to the negative x equals 4. We good with that? Now, looking at those exponents, I know we both have a base of 3. Both of them have a base of 3. But is one exponent double the other one? No. So I'm still going to use substitution, and I'm going to let m equal 3 to the x. So if I'm letting m equal 3 to the x, I have m plus m to the negative first power equals 4. And now when I have m to the negative first power, that's 1 over m equals 4. Again, not the format we want for factoring. But I can here, I don't want a denominator either. I can eliminate the denominator. Who remembers now, how would I eliminate this denominator? What would I do? Violet? Multiply everything by m. So we're going to multiply by m here, by m here, by m here. And when I multiply everything by m, I get m squared. Here the m's cancel. So plus 1 equals 4m. Now does it look like something that can be maybe factored, right? We have an m squared and an m. So I'm going to set it equal to 0 by subtracting that 4m over. So I have m squared minus 4m plus 1 equals 0. And right away, it's pretty clear to me that there are definitely no factors of 1 that add to negative 4, right? So this doesn't mean we can't do this, but I just can't factor it. What should I do instead since I can't factor it? Quadratic formula, you got it. So we're going to have m is equal to negative b, so that's a positive 4, plus minus the square root of b squared, which is 16, minus 4 times a, which is 1, times c, which is 1, all over 2 times 1, or 2 times a. So we're going to get m is equal to 4 plus or minus the square root of 12 over 2. Can I leave the square root of 12? No, because I can simplify that, right? So we're going to have m is equal to 4 plus or minus 2 root 3 over 2. As much as I would love to say this is the answer for m, it's not. Why? What's the last thing we can do to get our correct answer for m? Good. Pull out a GCF of 2. And when we pull out that GCF of 2, we're going to get m is equal to 2 plus or minus the square root of 3. Are these my answers? No, these are not my answers because now I have to substitute back in for m. So I'm going to have m equals 2 plus the square root of 3, and I'm going to have m equals 2 minus the square root of 3. And remember, m is 3 to the x equals 2 plus the square root of 3. 3 to the x equals 2 minus the square root of 3. Do we agree that the x is the exponent, and even if I end up with a negative, is it okay to have a negative in the exponent? Is that okay? Yeah, so even if I get a negative, that's okay. We're allowed to end up with a negative in the exponent. That's not a problem. But first we have to figure out how we're going to solve for x. Who remembers now what do we do to solve for x? Well, log both sides. So I'm going to have log of 3 to the x equals the log, and now I have to put parentheses, of 2 plus the square root of 3. That whole argument. I'm going to bring the x in the front. So I'm going to bring this x into the front. So now I'm going to have x times the log of 3 equals the log of 2 plus the square root of 3. We're now going to solve for x, so we divide by the log of 3. And one calculator-ready form is log of 2 plus the square root of 3 over the log of 3. If you type this into your calculator, we should get 1.199. Did anybody type it in? Are we okay? All right, for the other side, same thing. We're going to get x log of 3 equals now log of 2 minus the square root of 3. Solving for x, so we divide by the log of 3. And we're going to get x is equal to negative 1.199. Is it okay that I got a negative for x? Absolutely. We're always allowed to have a negative exponent. That's not a problem. All right, 2 more problems and then we're done for today. Does that exponent belong to the whole numerator or just the 7.5? Just the 7.5. So that exponent belongs only to the 7.5. How would I know if it were meant to belong to the whole numerator? I would have had to put parentheses around the numerator. Exactly. So we're going to do one step at a time. What do you think the first step's going to be? Violet? You got it. Multiply both sides by 9. And when we do that, we're going to get 72 is equal to 2 plus 7.5 raised to the negative 0.06x. Can I add the 2 and the 7.5 and get 9.5? How many people say yes, we can? Let's add the 2 and the 7.5 and get 9.5. How many people say no? Why not? Why can't I add them? Charlie? Yeah, because the 2's not raised. Well, even if it were raised to the exponent, we couldn't add them. But the 7.5 is raised to an exponent. And so we can't add them. They're like not considered like terms to be able to add them. So now I'm still trying to isolate the x. Since I'm trying to isolate the x, do we all agree at this point, since I can't add the 2 and the 7.5, that I should just subtract the 2? So now we have 70 is equal to 7.5 raised to the negative 0.06x. What should I do now? Shiv? Log both sides. You got it. Common theme. So we're going to have log of 70 equals negative 0.06x log of 7.5. And because I'm solving for x, I'm just going to divide by negative 0.06 log of 7.5. So now this is my calculator ready form. X is equal to the log of 70 divided by negative 0.06 log of 7.5. You guys, if you're typing this into your calculator, you absolutely need parentheses around that denominator. And I would, just to be safe, put parentheses around the numerator also. This is our calculator ready form. And when you type this into your calculator, you should get a negative 35.142. This is our answer. And is it okay for our exponent to be negative? Is that okay? Absolutely. Oh, actually, our exponent wouldn't even be negative, because a negative times a negative is a positive. So still good. All right, ready for the last problem. So before we do the last problem, I'm just going to recap something from the video you guys had to watch. Whenever you have the base of 10 raised to an exponent, how is it that we have to write it? With the anti-log, exactly. So that's going to come into play in this problem. So this is number 6. Okay, so right here I have log of x. If there's no base, what base is implied? Base of 10. So my instinct is, okay, well, can I simplify within my parentheses log base 10 of x? There's nothing I can do there. So where I'm starting now, I know this is a base of 10. This is a base of 10. I'm going to turn it into exponential. And when I say log base 10 of log of x, I'm going to say this is my argument, right? And this is the exponent. So now when I go to turn this into exponential, how am I going to write it? 10 to what? To 0.57 equals the log of x. Do we agree? Right off the bat, because, well, not right off the bat, at this step, I have 10 raised to an exponent. So immediately I'm thinking I'm going to need to write this as what? An anti-log. But am I done solving? No. So I can't write it as an anti-log just yet. So now I'm going to do the exponential one more time. So now I'm going to have 10 raised to the 10 raised to the 0.57 equals x. And now this is our calculator ready. but now I also need to write it as an antilog. How am I going to write this as an antilog? Okay, well, I have 110 raised to an exponent. That's one antilog. But then don't I have the other 10 raised to an exponent? That's a second antilog. So the way we're going to do this is we're going to say the antilog of the antilog of whatever that last exponent is, 0.56 equals x. This is the antilog format. And now the way you're going to type this into your calculator, we go to our calculator ready form and we just emulate that. So what you do is you're actually going to press a double exponent. So you're going to do 10 as your first base. And then do you guys see the little up arrow right above the division sign? You're going to press that and you're going to press 10 again. But then you're going to do another up arrow right above the division sign. Oops, I pressed the division sign, not the up arrow. There we go. And then that's where we're going to do the 0.57. And so your calculator ready should look like that. Press enter. And we are 5,192.210. Do I need that zero if I say round to the nearest thousandth? Yes. So we're going to get x is equal to 5192.210. This is our answer. All right, we are done for today. You do have homework.